Good morning and welcome back to Dr. Logic awkwardly does one more predicate logic proof example. Or actually probably two, because I couldn't decide amongst all of the various options that I had which ones I wanted to do, so I've picked two more interesting ones. The first one uh, involves statements of identity, so that allows us to look at some of the rules that we haven't actually had many examples about and see what we can do with them. So the first proof that I've got has three assumptions. The first one is that S is P and it is I, and everything that is both P and I is identical to S. So S is the only thing that is both P and I. And then I've got that C is P and it is L. And then third assumption, there is something that is both P and I and not L. These are my three premises, and from this, I'm going to prove that S doesn't equal C. Now, because this is a negation, so remember that this is just shorthand for it's not the case that C equals S, I can use my propositional proof strategy, which says if you're trying to prove a negation, assume the opposite, try to get a contradiction, and use negation elimination or negation introduction. So I'm going to assume that, in fact, C does equal S, and I'm going to try to get a contradiction. Now, I've got a couple of awkward formulas here, but you can see that there's a bunch of conjunctions, so there is never anything wrong in doing your conjunction elimination to separate them out. So conjunction elimination on lines 2 gets us PC on one line and LC on another. Now, interestingly, from the fact that C equals S, then from the fact that C is L, I can use substitution of identity and say, well, actually, S is also L. So that's substitution of identity, citing the identity on line 4, and LC on line 6, which is what I'm doing my substitution in for. So now, if I broke up this conjunction up here, I would see that I've got something, namely S, which is P and I and L. What I want, though, is, or what I know, because I know this because it's one of my premises, that I've got something that is P and I and is not L. Well, let's go ahead and give that thing a name. So I'm going to make an assumption at line 8. I will call it A. So I'm going to say, hey, PA and IA and not LA. So this is so that we can eventually do existential elimination. I've picked constant A because it doesn't occur anywhere else in the formula, which is a very good thing. Now, again, this is a conjunction. Why don't I break my conjuncts down into various parts? For instance, I'm going to separate out, there, let's make that clearly an I. I'm going to separate out the left-hand conjunct from line 8, and then the right-hand conjunct. Now, where else have I got conjunctions? Because I've got conjunctions all over the place here. I've done some elimination on this one. I've done some elimination on this one, but I still have this one up at the top. And in particular, let's pull out this universally quantified sentence because it's probably going to be the easiest. So for every X, if it is both P and I, then it equals S. So that's another conjunction elimination on line 1. Now, whenever you have a universal statement, you should do as many eliminations as you can. So I've actually got 3 different constants here, C, S, and A. I'm going to do elimination on A first because it's the one that I introduced for this existential elimination assumption. So what I do is I ignore the quantifier, erase all the variables, and replace A in each of them. So this says that if PA and IA, then A equals S. Pretty cool. Oh, I hope I don't run out of space. So that is for all elimination line 11, and I will try to start writing smaller. What you can see here is that at line 9, I have the antecedent of line 12. So I can do conditional elimination, lines 9 and 12, to get that A equals S. This is cool. Having all of these identities means that I can do more substitution. In particular, at line 14, I can say if A equals S, well, then I have LS up here. I can do a substitution and get LA. So substitution of identity, lines 7 and 13, LA. But this is a contradiction with not LA up here. Now, at this point, this is good because I've gotten a contradiction, because that's what I was trying to get from my assumption here at line 4. Less helpful is the fact that it involves A. I can't get out of my subformula, my subproof here, with anything involving A, because A is the constant I introduced in my assumption at line 8. And one of our rules for existential elimination is that you can't bring out a formula that uses this, this constant. So I need something else. Well, let's look at all the identities we have. I know that A equals S, and I know that C equals S. This means that if, here I'm going to take S equals A, this is the just applying symmetry to line 13, then if C equals S and S equals A, I know in fact that C equals A. So that's transitivity of 4 and 15. Now I can get something that will contradict one of my lines up here that doesn't involve constant A. I can do this by taking line 10 and substituting C for A using substitution of identity. I'm going to write it very, very small because I'm running out of space. So we have not LC, substitution of identities, 16 and 10. This line I can bring out of this subproof because it does not involve the constant that I introduced at line 8. And if I check the constant at line 8, the only assumption that it occurs in is the one that I used to start the proof. So both of my provisos have been met. So let's go down here and bring out not LC, and I'm just going to run out of room. This is existential elimination, lines 3, and then the entire subproof, 8 to 17. And now, underneath my assumption that C equals S, I have my contradiction at line 6 and 18. So you might not be able to see it, but down here at line 19, I'm introducing my negation. So negation, introduction from lines 4 to 18. So this one is pretty cool because we got to use substitution of identity, we got to use symmetry, we got to use transitivity, and you know, it was cool. Trust me. All right. Oh, I've got one more that I want to do, but I don't want to make this video too long. So I think I will stop this video and then do the other one in another one. So if you don't want to watch loads and loads of examples, you can just stop here. But join me again in just a few minutes and I'll do the other one because it's a cool one that again involves the existential quantifier, but not necessarily existential elimination. So take care. See you in a bit. Cheers.